Okay, so the fundamental theorem links derivatives with integration. Derivatives we did last semester, right? Derivatives, finding derivative, slope of the tangent line, things like that with what we're doing this semester, area under the curve, integration, right? So there are two parts to this. We're going to talk about part one. Part one's the evaluation part. Today we're going to talk about part one. Okay, so this is what it is. Okay, so if a function is continuous over an interval and capital F of x is any derivative of f of x, then. Okay, so the big thing today, we're doing the same thing we've been doing. Nothing has changed. The big difference today is that we're going to have bounds. Bounds. Okay? We haven't had bounds. The ones we've been doing, you look at the homework assignment that we were doing. There were no bounds. They're called indefinite. That's why they're called indefinite. Today we're doing what's called definite bounds. So how do you do that? Well, the first thing you do, when you see capital F of x, that means antiderivative. You know how f prime meant derivative? Capital F means antiderivative. That's all that means, okay? So if we have a function, we find the antiderivative. That's exactly what we've been doing, just like your homework. The new part is the evaluation part. So what we do is we plug in this value to the antiderivative, plug in this value to the antiderivative, and subtract them. That's the new part. This is the new part right here. Okay? All right. So here's an example. This is the problem here. We started with this problem. Okay? First thing we do, find the antiderivative. The antiderivative of 3x squared is x cubed, because you add a power and then divide by that new power, it leaves x cubed, right? So that's the antiderivative. That's where we stopped the last couple days. Evaluation part. Okay, so we're going to take this guy and I'm going to plug in 5 first. Then I'm going to plug in 1. Whatever I get here, I'm going to subtract it from what I get here. That's it. Plug in, subtract, that's the new step. Plug in, subtract, plug in, subtract. Okay? Anytime you see the capital F, it just means antiderivative. Okay? So let's do number one, example number one. It might sound a lot complicated, but trust me, it's exactly what we've been doing. Okay? So the first step, find the antiderivative of this guy. How do I find the antiderivative of negative 15x squared plus 6x? Mm-hmm. Say it again. Say a little. I need antiderivative. So I need to do antiderivative. So how do I find the antiderivative for that guy? You did it on your quiz. This is not new. You guys did it on your quiz. You guys did it for your homework. How do I find the antiderivative of the yellow? Don't even worry about the bounds right now. The bounds are meaningless right now. How do I find antiderivative? Like, what's going to be the antiderivative of negative 15x squared? Right? Add a power, divide by the new power, right? We've done that. Okay. So negative 15 x cubed divide by 3. Right? We've done that before. Plus 6x squared divided by 2, or times 1/2, whatever you want to do. Right? That simplifies to negative 5x to the third plus 3x squared, right? That's where we stopped up to this point. The new thing is that we have bounds. How do we deal with the bounds? You plug them in. So now we're going to evaluate it from 2 to 1. So the first thing I'm going to do is I'm going to plug in 2 everywhere there's an x. So there's a 2 here, and there's a 2 here. Then I'm going to plug in 1 everywhere there's an x. There's a 1 here, and there's a 1 there. Solve it. So on the left, I get negative 10 plus 12. Oh, sorry, yeah. This one's supposed to be, wait. This one's cubed, right? Yeah. Yep. So that's going to be negative 40. This is going to be negative 5 plus 3. So we get negative 28 minus negative 2. We get negative 26. So that means the area under the curve for the yellow, if I was to find area under the curve for the yellow, from 1 to 2, from x equals 1 to x equals 2, so not very thick, very thin slice, it would be negative 26. Okay? That's the process right there. The calculus part is review. We've done this part. This is the calculus part right here. That was the calculus part. We've done that before. Everything that I didn't circle is just plugging in numbers, plugging in numbers, and then simplifying. That's something you guys have been doing for a long time. So this process it's not more difficult. It's just an extra step. It's the evaluation part. That's all it is. Evaluate, in math, when we say evaluate, it means plug in and get an answer. That's all it means. Okay, all right, so let's look at number 2. I'm not even concerned about the bounds right now. Bounds don't even matter to me. I'll worry about those after I have the antiderivative. My first job is to do the antiderivative. How am I going to find antiderivative for this guy? He did it about 20 times in the last 2 days. Exactly. We're going to use U substitution. We're going to use U substitution, right? We're going to move the bottom up. We don't want a fraction, right? We don't have a quotient rule for antiderivatives. So we're going to move it up. So we have 4x squared. And then I have 2x to the third plus 3 to the negative 3 power dx. Okay? Which one's going to be u and which one is going to be not u? Mm-hmm. The bigger power, yeah, always the one with the bigger power is going to be u. In that case, that's this guy. This guy is going to be u. You're doing exactly what you did the last couple days. You guys did it quite a bit. This part hasn't changed. Plus 3 du is 6x squared dx. Divide by 6x squared. 1 over 6x squared du equals dx. I haven't changed anything from what we've been doing. This is exactly what we've been doing. Now I'm going to plug in u and dx. So 4x squared is going to stay. This is going to become u. And then instead of dx, I'm going to put 1 over 6x squared du. I want the x's to go away. They do. X squared and x squared. And then in fact, the 4 and the 6 too. I can reduce the 4, I can divide them both by 2. So I have 2/3 in front. Okay. Now I can do my antiderivative. Add a power, divide by that new power. So I have 2/3 times. If I add a power, I get -2. Divide by -2 or multiply by -1/2. Here's the difference. I'm not going to have to put a plus c. I don't put a plus c because these have bounds. We only put plus c when there's no bounds. We have bounds here. So I'm not going to have to put a plus c because I'm not technically done with this because then I got to do the evaluation part. So I have -2 over 6 u to the -2. U is 2x to the third plus 3. I'm going fast because we've been doing this the last 3 days. So that's why I'm going fast. So if you're trying to catch up by writing like this, don't. Just use your skills. Use your skills we've been doing. You guys can do this. You guys did a whole bunch of problems yesterday. Okay? Okay, so now I can reduce this guy actually. This is 1, this is 3. This is the exact same thing we've been doing. Okay, so I have -1/3 Okay. So now I got to plug in. Plug in 1, plug in -1. Plug in 1 first. There's only one spot to plug in. Plug in 1 on the first one. Plug in -1. Top goes first, bottom goes second. Simplify. -1/3. -1/3. So let's see. 2 times 1 plus 3 is 5. -2 times -1 plus 3 is 1. Okay. How do I deal with a negative power? Move it to the bottom, right? So instead of 25, it's going to be 1 over 25. So it's going to be -1/3 times 1 over 25. And then this is going to be negative 1/3 times 1 over 1, because if you move 1 to the bottom, it just stays 1. So you get negative 1 over 75 minus negative 1/3. Common denominators, going to be 75. So you have negative 1 over 75 plus 25 over 75, which is positive 24 over 75. Done. Okay. So it's just doing the same thing, and then once you get your antiderivative, plug in the top bound, plug in the bottom bound, simplify. Sometimes you got fractions to deal with. It happens. Just get a common denominator. Okay, so the area under the curve from negative 1 to positive 1 is going to be 24/75. Very small area. Not even a whole unit. Okay. My biggest is when people see this, watch, I'll show you. When students see this, oh, I know what to do. Just use substitution. When they see this, I have no clue. How do I do that? It's the same problem. It's the same problem. Okay. Sometimes what happens is the bounds get in the way of what you're supposed to do. Do the same thing you would here. First step's always the same, right? Once you get that, that's easy. Okay? That's the only extra step. So don't let the bounds get in the way. You see bounds and you kind of tense up a little bit. No, that's for later. The bounds are for later. Okay? Okay, so let's look at another example, number 3. So again, picture this had no bounds. Picture this had those two guys weren't there. It's what we've been doing. It's exactly what we've been doing. The bounds are just there for the second part. Okay, so how would I rewrite this so that I could do the antiderivative? Mm-hmm. Mm-hmm. So the root is going to be negative 1/4. What about the other part? What can I do with the 5, divided by 4? There you go. Move it to the front. Move the power. Let me highlight it. Move, not the power, the fraction to the front. And then do what you said. Right? If it was 15x, we couldn't do this. Okay? Same problem, we just rewrote it. Again, don't worry about the bounds. Don't worry about the 2 and the negative 1. We'll deal with that later. All I need to do is antiderivative for this guy. You had problems like this. You had problems like this on the notes. You had problems like this on the homework. The practice, right? This is going to be u. Go through our process. Move everything back in. 15/4 stays in front. So u is 5x plus 6, so that's going to be u to the negative 1/4. Dx is going to be 1/5 du. I'm going to take the 1/5 and move it to the front. So it's 1/5 times 15/4. And then I'm going to do the antiderivative. So the antiderivative is going to be 3/4 divide by 3/4, which is the same thing as multiplying by 4/3. No plus c, I don't need a plus c because it has bounds. If we were done, if this was our last step, like you guys have been doing, you put a plus c. But this guy doesn't need a plus c since this isn't our last step. We got to do the evaluation part. Okay, so multiply 3 fractions. I can cancel. That makes a 3. That makes a 1. That makes a 1. That makes a 1. I can just divide, reduce. So I'm going to get 3/3. So just 1. They all multiply down to 1. Okay, nice and easy. So I'm going to put u back in. Now the evaluation part. Now the bounds come in. So now I got to plug in 2 for x, negative 1 for x, subtract, done. Okay. So let's plug in. So first thing I'm going to do is plug in 2. And then I'm going to plug in, oops, not x. 2, negative 1. Okay. So I'm going to get 16 to the 3/4 power minus 1 to the 3/4 power. So what does 3/4 power mean? So when I have something to the 3/4 power, what does that mean? Why is it a fraction? So the bottom's the root, the top is the power, right? So we can do, which one do we have to do, the root or the power first? It doesn't matter, whichever is easier. So for 16, since we can't use a calculator, would it be easier to cube it or take the 4th root? Take the 4th root, right? What is the 4th root of 16? What number 4 times makes 16? 2 times 2 times 2 times 2, right? So 2. So the 4th root is 2. Cube 2. When I cube 2, what do I get? 8. So this guy simplifies to 8. For 1, it doesn't matter. If you cube 1, you get 1. If you take the 4th root of 1, you get 1. So it's just going to be 1. 7. area under the curve from -1 to 2, +7. Okay? So like I said, that part there, what we've been doing the last 2-3 days. That part is what we've been doing the last 3 days. 2 days of notes and then yesterday practice. That part hasn't changed. Use substitution, do all that stuff. The other part, the part I didn't, is just plugging in. Plugging in, subtracting, simplifying. It's not difficult for you guys. At this level, it's not difficult to plug in something. You guys can do that. Okay? So really, this day is just more about practicing this part. Good practice. It's good practice for use substitution. Okay? All right, so let's look at number 4. Number 4. So now we have a trig. Doesn't matter. We're still going to do the same thing. You guys had trig yesterday. We had trig on the notes. You guys had trig on the homework assignment, on the practice assignment. Again, don't worry about the bounds. The bounds aren't there. The 0 and the pi/4, they're not there. Don't worry about them. We won't deal with them till afterwards. What's the first thing I should do here? Rewrite it, right? Rewrite it. Get rid of the root. Rewrite the power. So instead of square root tangent, I'm going to put tangent of x to the 1/2 power times, and then I'm going to rewrite this guy squared. Same problem, just rewritten. So I have three options. I can make tangent u. I can make secant u. Or I can make secant squared u. I have 3 options. How do you decide between the 3 of them? Is it the yellow, the green, or the blue, or the orange? Here's how you decide. If I were to use tangent as u, what's the first step I would do? Derivative, right? Is the derivative in there? Is the derivative of tangent also in there? What is the derivative of tangent? No. Let me ask you another question. What is the derivative of secant? The derivative. What is the derivative of secant? Which one has the derivative also with it in there? Is it tangent or is it secant? So with the derivative of secant is secant tangent, right? Secant tangent. So if I make this guy u, it's gone. I have tangent there, but is secant there too? No. What's the derivative of tangent? Secant squared. So if I make tangent u, it's gone. Is its derivative in there? Yeah, that's the guy I want to go with. When that happens, that's the guy I want to go with. I want to go with the guy whose derivative is also in the original equation. That's tangent. That's tangent. It's like the one we just did. No, not that one, because it only had one choice. The one we did earlier, right? This one here. I had 2 choices. 4x squared or 2x cubed plus 3. I chose the bigger power because what's x cubed's derivative? X squared, which was in there, right? That's the thought process behind that. It's the same thought process, just with trig. So I'm going to choose u for tangent. Du, secant squared. divide by secant squared. Substitution. So tangent no longer there, becomes u. Secant squared still there. Now plug in for dx. Okay. Everything's back in. Okay. Secant squareds are going to cancel out, which we wanted them to. So now we're left with u to the 1/2. Antiderivative. Oops, don't need that anymore. So we have u to the 3/2 divided by 3/2. Put u back in. Now the evaluation part. Now the bounds come in. Now the bounds are going to come in. Got the antiderivative. It's 2/3 times the tangent to the 3/2 power. Now I'm going to plug in pi over 4 first, and then 0, and then subtract them, and I'm done. So I plug in pi over 4 and 0. So tangent of pi over 4, tangent of pi over 4 is 1, positive 1. So I have 2/3 times 1 to the 3/2 power. Tangent of 0 is 0. What is 1 to the 3/2 power? Cube 1, then take the square root. You still get 1, right? Times 2/3 is 2/3. 0. Cube 0, find the square root of 0. Still 0. Subtract. Area under the curve is going to be 2/3. Again, this part, you guys have been doing for the last 3 days. That part. Like I said, if I were to give you guys the same problem, except without the bounds, you know where to start. Find u. Do u substitution, right? It's like what we did before. The only difference here is after you've done all that, plug in the top bound, plug in the bottom bound, subtract them, you're done. It's an extra added step, but it's not a step that's hard. It's just you plug in. Okay. Let's see here. What time we got? I don't want to start on the next problem because the next problem might take us a little bit longer. Okay, so tomorrow we'll finish the notes tomorrow. Friday I'll give you the practice. I'll let you do the practice for this. So tomorrow we'll finish the notes. Friday we'll do the practice, and then yep, we'll go from there. Okay.